Hello all. Today we are going to see a problem from GATE 2020 first paper of mechanical, question number 39. So you can see that you are being given a system like this. This is about the bolted joint when they are loaded eccentrically at some with some eccentricity. So before proceeding into the problem, you can check out about details about this problem in following NPTEL lecture, where the lecture about eccentrically loaded bolted joints in design of machine elements, one by Professor G. Chakrabarti, Professor B. Methi, and Professor S.K. Roy Chaudhary from IIT Kharagpur. So let's look into the problem. So this is the system basically given with all the dimensions and eccentricity. So before solving the problem, let's see this. So if you have a system like this with eccentricity E and load P, with this ABCD being the bolts and this being the radius from the center of centroid. So you will get two types of shear force. Basically, one is because of this load you're going to get primary shear, and there is a moment that is being developed. Because of that you will get secondary shear. So a bolt will undergo these two forces, and it will have the resultant of these two basically. So let's see how to solve this. So what do we have first? At first you can view this whole system as a rod or a bar supported from one end and constrained at one point, actually, right? So if you equate the forces, net force is equal to 0. That means let's take a resistive force which is here. Of course the direction will be reversed to this so that it will balance, but let's go with this. So what you will get is minus R minus P, since it's pointing down, is equal to 0. That means P is equal to minus R, basically, right? So same way what happens is you have four bolts which are identical. It's given as identical, right? So what happens, these four bolts has to take care of this particular force which is given as 10 kilonewton. So what you can do is so you can equate net force is equal to 0. So now let's name it as A, B, C, D. That means your FA plus FB plus FC plus FD is balancing the force here. So instead of P you have 10 kilonewton, and all these are identical. So what you will get is your FA is equal to FB is equal to FC is equal to FD, which is 10 by 4, right? 4 are equal, so you will get 4A or 4FA or 4FB. So what you are having, one force is equal to 2.5 kilonewton. Okay, so this is your primary shear. Primary shear, as it was shown in the previous slide previously, that the total load divided by the number of bolts. So this is how you actually get that formula. So this is your primary shear. Now why do we call it shear is because if you see here what is happening, if you see from side view, your bolts are actually, so if this is your bolt, this is your structure, your bolt is actually getting loaded like this by the by the other forces. So it is actually inducing shear. That's why we call it primary shear or secondary shear. Yeah, so let's take again 4 points. This is the center point, right? So now in this structure, let me simplify it. You're having a load like this. Let me take it as P. Okay, and you have some eccentricity. Let's say this as R, because in this case everything is same, R1, R2, R3, R4. So I'm just taking it as R, A, B, C, D. So how will the forces behave? How is it supposed to behave? You are having a moment like this, right? So that means about this origin, let's take this as origin. What you can get is about that origin, you're going to have a moment like this because of P. So that is P into this distance, right? P into E distance from that point of load. You're going to get a moment like this. So you have to balance this moment. How will you balance this moment? Is providing a counter moment. So this is being provided by the bolt, right? So your total net, now what you can see is your net moment has to be from the bolt has to be in this direction to counterbalance it. So now if you draw again, what can you say? How will the force be? So now it has to come like this. So if I look at this particular arm, if it has to come like this about this point, that means the forces has to be like this, right? So let me take another color. So your force is going to be like this. Same way, if it has to go like this, it means your force is going to be like this. Same way here and here. So you can see the force directions, right? So let me put F2B, F2A, F2D, F2C. Now since the radius is same for all the cases here, so what we can do is take net moment is equal to 0, right? So the net moment is coming from two sources. Let's see what are the source. One is due to this and another is due to this. So these two has to balance. So what you can write is from here, what you can actually write is F2A into R, that is one moment, right? Same way F2B into R plus F2C into R plus F2D into R, and again minus of this particular moment by the eccentric load PE. So now if you use this, what you can write is F2A plus F2B plus F2C plus F2D is equal to PE by R. Now the point to be noted is here the system is very symmetrical and identical, all the bolts. So your all F2 will be equal to F2B, F2C, F2D. Okay, so finally what you can write is this quantity is equal to, from here So what you can write is 4, let's say F2A, because all are same, PE by R. Therefore F2A is equal to PE by 4R. Your E is this distance. Right, let me highlight it nicely. So your E is this distance, so that is this distance from the load to its this central axis. So your E is going to be how much? 300 plus 100, so 400 mm. Okay, and your R is this distance. So how will you get that? So if you see, look at this, this is a right angle triangle. So what are you actually getting? Okay, so here 50, here 50, so your R is going to be 50 root 2 mm. Your P is 10 kilonewton. And let's use this value. So what do you get here? 10 kilonewton into eccentricity is 400 by 4 into 50 root 2, which will turn out to be 114.142 roughly kilonewton. So your secondary your primary shear was 2.5 kilonewton shear force basically, and secondary shear was 14.142 kilonewton. So now if you look at the bolted joint, let's take those 4 points again. So you will have, okay, because of the load you're going to have something like this. So let me just draw here. These are all primary forces, right? Let me draw here F1. Now you have secondary forces. Okay, these are all at, if you look at the geometry, these are all at 45. Yeah, here angle will be 45. This you will get from the geometry. Okay, so now what you can take, let me just take this. So your magnitude of the resultant force is given by F1 square plus F2A square plus 2F1 F2A cos theta. So in this case, if you see, theta is 45 degree. Okay, so using these three values, what you're going to get is roughly 16 kilonewton. So this is your final answer. So I hope everybody understood the problem. You'll get the same answer if you actually plug in these values from the figure into the formula that I have shown initially also. But it is very important to understand the how we got this problem, so that you can apply these principles in even very complicated systems and still be able to figure out how to do this without remembering the formula. So thank you.